Solve the following word problem, show all of your work, and explain your steps. Be sure to show your graph in Desmos and discuss which portion of the graph is used for each question. Javi and his friends are using a slingshot to launch water balloons down a field. The water balloon is 3.2 feet off the ground when it is launched at a 29-degree angle. Its initial velocity is 78 feet per second. Alright, so first we have to write these equations. So for the x part of it, we would just have to write the velocity times time, so that would be 78t times the cosine of whatever angle you're launching it at, so 29. For the y part of the equation, it would have to be -1/2 times the gravitational pull, which is 32 feet per second. So we would end up having -16, and then we have to do times t squared, like that. Then we have to add the velocity times the time, so 78t. Then you have to multiply that 78t times the sine of whatever angle you're launching it at, just 29. And then lastly you have to add whatever the initial height is, so 3.2. So let's graph this parametric equation first. So I have to make sure that we're in degrees and not radians. So we're going to have 78t times cosine of 29, comma, -16t squared plus 78t plus 3.2. Not 32, plus 3.2. Not y plus, yeah, okay. And then let's just make this like something that we would cover the entire thing. Okay, yeah, that's good. Okay, so basically we have to look at the time the balloon reaches its maximum height. So basically, in order to do that, we have to replace the t's in this y equation with x's, just so we can solve for that. So this would be -16x squared plus 78x times sine of 29 plus 3.2. So if we put that in Desmos, we would get -16x squared plus 78x times sine of 29 plus 3.2. The time the balloon reaches its maximum height, this would be, so basically what we're seeing here, we can see that the time the balloon reaches its maximum height is 1.182 at 1.182 seconds. So this would be 1.182 seconds. And then the time the balloon hits the ground, it looks like this would be 2.445 seconds. And then the maximum height of the balloon, it looks like it would be 25.544 feet. And then you have to solve for the height of the balloon 1 second after Harry and his friends launch it. So basically that means that we have to plug in the we have to plug in the 1 into this y equation in order to solve for the height at 1 second. So basically we would do -16 1 squared plus 78 times 1 times sine of 29, that's not, and sine of 29 plus 3.2. So that means you would end up having -16 plus 78 times the sine of 29. I'm also doing all this on my Casio, by the way, so you can see this, plus 3.2. So after plugging all of this in, you end up getting a height of 25.015 feet, roughly. Okay, and then we have to, oh yeah. And then you have to look at the distance down the field away from Hawaii when the balloon lands. So basically, in order to find this, we would have to find basically you would just have to plug in 0. So because it's basically when the balloon lands, that means the y value would be equal to 0. So basically, we would have to use this we would have to use this 78 equation, and we've already found that the balloon lands on the ground at 2.445 seconds. So basically, we just have to plug that in into the x equation. So that would be 78 times 2.445 times cosine of 29. So 78 times 2.445 times the cosine of 29 is roughly 166.8 feet. Roughly 166.8 feet. And then you have to look at the distance down the field when the balloon reaches its maximum height. So we've already found that the balloon reaches its maximum height at 1.182 seconds. So now we just have to plug 1.182 into the x equation. So this would be 78 times 1.182 times cosine of 29. 78 times 1.182. Then that times cosine of 29 is going to be roughly 80.64. 80.64 feet is the distance down the field when the balloon reaches its maximum height. And the distance down the field 1 second after Hari and his friends launch it. Basically, for this one, we just have to plug in 1 into the x equation. This would be 78 times 1 times cosine of 29. This would just be 78 times the cosine of 29, which gives you a value of 68.22. And there we are done.